and I'm going to create a Unit 11 project. I'm going to create a package. I'm going to try catch. Maybe I'll call it handle try catch. Handle that try catch. That's my project. That's my package name. Create a class. Again, it's called a try catch. It's going to have a public static void main. Okay, our typical program here. Okay, so I'm going to do something here really quick. I'm going to go system dot lang. Was it lang? Was it Java? Well, I don't remember the tree, but I'm going to type in one of these, like arithmetic exception. Let's see if that takes me to, I'm going to right click on the word and go to open declaration. Okay. So if you type that word here, it takes you to right to that class where the exception occurs, and you have the arithmetic exception. You have IO exception for input output, and if you right click on the class and just say open declaration, it will take you right to that class. So here's the class that will throw the error. On the left side here, I want to show there is actually a tree here. I'll try again. So right click on that class name again, open type hierarchy, maybe F4. Yeah, F4. So if you press F4, maybe this is what I want to show you here. So if you press F4, you see that the object class here. Okay, if you click on that tree, and you can select one of these little icons here to show you more information about these classes, but let's pick the first one here. So under the object, you have the type of functions that are built into the object class. If you double click on it, it's going to bring that up. Okay, this is the parent class of all the classes, right? So you can see that it's all here. All the methods are here. You see something very familiar called the toString. If I double click on the toString, it's inside the object class. You see that this one here is the method that you can override. I showed you last time as well. Let me turn on the word wrap here. Where is it at? Well, it's up here, I'm sure. Okay, so this is the toString method that you can override because it's part of the object class, right? So that's there. And if you go down to the throwable, right, so you see a whole bunch of other methods. You see all the constructors here. Okay, you have and the stack trace, right? Get stack trace, it's all here. And keep going down until you find the exception. Under the exception, you have the runtime, and then you have the arithmetic exception. Okay, so that means this arithmetic exception is part of your runtime exception. That means you only encounter this error when you run the program, right? It's during runtime, like you do maybe some type of conversion or something like that, then it will occur during that time. Okay, so just to show that you can actually go right into the class that will produce this type of error. I mean, any class in your program. If you write your own classes in here, you can do the same thing too, right? Okay, so I'll leave that there. So let's write a program here, a very simple calculation based on the division by zero. So if you type like system out, if I do 5 divided by 0, right? We know that's illegal. But as you can see, it doesn't give you an error. The system doesn't know that. It doesn't treat that as an error. Okay. And if you save this, if you run it, okay, well, it throws by 0. This is different. Last time I tried it, it didn't say throw by 0. Usually you will have like a the answer is like infinity or something. If you have infinity, it just still means same thing. It's division by 0. Okay, so in this case, for example, it's illegal. As you can see, it doesn't catch that error when you write the code. When you run it, then it generates this error. And as you can see, it actually stops the program. If I write another statement below it, if I do like sys out and just say hello, right? 2 statements. And if you run it again, okay, you see that the second statement didn't get to run. Otherwise, it should have run line 7, throws the error. It should keep going until the end of the program. But since we didn't catch it, right, it terminates the program. And this is something we don't want to do, okay? Because this is not it should be a fatal error, okay? So if you don't catch it, that's what you get. The program stops. But if you catch it, because this is a division by 0, then you can catch it. It says it's arithmetic exception, right? It's part of the math exception that class we just looked at. Okay, and this here is called the stack trace. Okay, it shows you where it starts. So it starts from the bottom up, going all the way to the top. So if you have more methods, let's do this. If I go in here and write another function, like right here, we'll write another method here, public static void, which is going to say print. Okay, print. And I'll put this print inside, cut that, put it inside here. Then print that inside here. Okay. And we'll call the print function from the main program, right? So it's going to call print, and then instead of print, it's going to print this message followed by 0, and then it crashes right there at line 12. And then it should not run line 8 because we have the error there. Okay? So now if I run it, let's see what happens. Okay? So you'll see that it has a stack trace right here. Okay. It tells you, if you again look from the bottom up where this error actually occurs, it goes all the way back to the main entry of where this error can be traced back to. So it starts at the main program. As you can see, the try catch, this is the package, right? Package, I call it try catch right here. The class is try catch, a function called main. Okay, at line 7, I call in line 7. I call that, it traces that. If you go there, it finds the print function. So it goes to the handle again, try catch the print function, line 12, and that's where the error occurs. Okay? So it traces everything from however convoluted this code is. It will find it for you. And again, because we didn't catch the error, it crashes, it stops right there. So that's why you don't see this line here. So to handle this issue, you will check this number 0, make sure it's not 0, right? If it's in this case, you can't check it because it's a constant number, so you can't do it. But if it's a variable name, you can. So then, to prevent this from happening, we'll wrap this statement here inside a try catch. Okay, so let's do that. I'm going to go in here and put try. Okay, I'll put this inside the try because I know that this denominator could be 0, so that could cause this problem. Otherwise, I wouldn't need to try it, right? Now, for every try statement, okay, you must match that or pair that with either a catch or a finally clause, a block. Okay, so you could say try that and then just put finally, and then you don't have to put anything there. That's okay if you don't want to. But so now, even though we didn't catch the error, okay, it should not crash our program because we tried it, and since we didn't catch it, it will catch it automatically by the server, by the system, but we just don't output information. So if I just save this and run it again, okay, well, I guess we do have to catch it then. I thought we don't have to, but okay, maybe so we have to catch it then. All right, so let's put a catch in it. So finally, I'll talk about that in a minute here. Let's put a catch in here. So catch, we'll just do one catch. The catch here, if you don't know what it is, this example we know because this is a arithmetic exception. So I could put that in there. It says catch, put the class name, and then put a variable name. If you don't know, then you can use another keyword. But for now, since I know that it's arithmetic, so I'm going to call arithmetic exception. And by convention is usually the word exception attached to the name of your class. So if you're going to write your own custom class for catching this type of exception, it's recommended that you should always attach it with that word exception, like my own error exception or something. Okay, and then you put a variable name over here, just another any variable name. Usually letter E is very common, or EV for event because it's an event. Okay, and then now if you want to know what that error is, so once you catch it, I showed you a while ago, like this window here, you probably won't see this message anymore. Okay, so if you don't catch it, then it will throw this for you, at you on the screen here. But once you catch it, even though you don't put any messages, I believe you shouldn't see anything there. Let's see. Okay, so you can see that it runs just as if there's no error. Okay, it runs it. This is an error message. We'll throw that in here. And if you don't display the error message, then the user would not know it, and as if there's no error. Okay, and then it prints the next statement, which is the hello string here. So if you don't know what the error is, since you catch it, it's all hidden inside this object or this variable called E here. The stack trace we just saw, it's gone. It's hidden now. If you want to see that message, then you want to say E print stack trace. Okay, and you don't have. I think I have to put anything here. Yeah. If you put E print the stack trace, just mean now show the error message. But it doesn't mean your system is going to crash. It just means show the error where it occurs, and so I know if there's any error, then catch it and print it so I can see it. This is only happen when you are coding your program or you're debugging. In a real application, you don't want to throw that out to the user. Okay? So I can still capture, I can still see the message, but my program still runs. As you can see, it runs, it prints the hello statement here, right? I'm sorry, what? Yeah, right, sort of, yeah. You can hide it. You catch it, you don't have to display it. But usually if you catch it, you want to handle it. How do you handle this? So you want to say, oh, it's a division by 0, the number is invalid, please try again. Okay. So if you don't want to display the trace, you can just omit that, right? And then here you can put your own message. You can say, system, what type of message is this? Because the stack trace shows you a lot of information here. It shows you like which method calls it, where it is like that, and this is the actual message. That's the message. That's the one that causes the error. So if you just want to show that, I believe if you just type in here, I want to show the e.getMessage. Okay. You have the get message. There's a bunch of if I go back again, e dot, you see they have a get message, get cause, what caused it, right? Get the stack trace, and so on. So usually get message is the one that's very helpful. It tells you what that message is, and then so you know that is a division by 0. So you say if the message is division by 0, then output that to the user, because the arithmetic exception is not only caused by division by 0. Okay, it could cause by something else too. Another possible exception error for the arithmetic will be like if I do, let's just say that in here I have an integer, right? Int a is equal to let's do this. I have a string s that has a 1 right? 1 and you want to convert that to integer parse s. So you want to convert that to an integer, right? As you can see, it thinks that it's gonna. So what that does, if you have like the number 11 here, right? Because it's a string of 11, the number 11, which is a string. If you convert it using this function, then it's gonna convert that to an integer of 11, and you can do mathematical operation with that. But if it's a string, then you can convert that. So that one, it should be fine. If I save it, if I run it, shouldn't be any error. There's no error there. But if I put like I happen to put a letter A or other invalid characters there, other than digits, then if I run it, you see that it has the error, right? It catches the error. Oh, different type. Okay, I thought it's the same one, but so many of them. So this is another error here. I have a number format exception. So many. Okay, so this one here, I didn't catch it. That's why it crashed. Right? I didn't catch it. That's why I didn't see the message hello anymore, because it crashed it. What would be another format operation? Can't think of one. Okay, so we just discovered another one. The number format exception. I'm trying to format, convert, a string to a number, and that's illegal. So I caught the error. And then to catch that, you would do the same thing, right? I will write another catch statement. Oh, okay, so I have that type of integer number format. I can also say, okay, now also catch this number format exception. And again, I'll just use the letter E there. And whether or not you want to show the message, it's up to you. Okay, but usually you do. So we're just going to system out the actual message, e.getMessage, so we know what it is. It should say this message here. Well, let's see what it tells us. Okay. So now I have 2 catch blocks, one for each very specific type of error. Okay, and if I run it, well, it just say input string 11a. That's the message. And again, if you know that, then okay, then you can make it a little bit more friendly how you rephrase that. But otherwise, here again, you catch a different type of error. Okay, so you can catch multiple types of errors in here, and if I leave this in here as well, the original one, okay, what happens is once you detect an error here, it stops there. Okay, it's not going to go to line 15, 16, and then throw another error. Okay, the first error it catches, it will throw that error, and then it will skip the entire block, and it continues from there on. Okay, so you're not going to see the second error. I believe it's going to jump out of that. And so you see we only detect the first error, which is the division by 0. Because if you didn't catch it, it would have stopped your program anyway. Okay, so execution jumps out of the try block as soon as it finds or it detects the first type of error it catches. Okay, and then anything after that will be ignored. And then, so the flow of this try catch is it goes into the try, it runs every statement. If there's no error, then it will skip all the catches here and goes into the finally block. Okay, this finally block here always runs. Okay, whether there's an error or not. Right? Always runs. And just to show that, I can put a message here, sysout finally block here. So you can see that is going to be displayed to the console. Okay, so I have an error. It's division by 0, but it runs in the finally block. Okay, if I go up here and remove that and catches the format error, I got the format, and then it still prints the block. If I remove all of them, there's no errors, nothing there, okay, it will still print the finally block. Okay, and if I don't catch them, let's see what happens if I don't catch them at all. Right? I remove both of those catches, and I have an error. The first error, okay, it prints the error message. Okay, so it terminates the program, but it still prints that finally block anyway. Okay, whether you catch it or not, if you have it, it will print that for you. And this is very useful because now I can do some things with the program before it crashes. Like if you write data to a database or to a file, so you always, back up your files or save your files first before the program crashes. It's like a catch-all. It's like a safety net for you.